Have you ever looked at a massive calculation and just thought, there is no way I can solve that without a calculator? Well, today we're going to crack the code on a math hack that lets you find the very last digit of pretty much any huge number in seconds. Let's dive in. So take a look at this beast of a problem. I mean, 633 to the power of 23? That seems impossible, right? But I promise you, in just the next few minutes, you'll be able to look at this and pretty much solve it in your head. Just stick with me. Okay, so first things first, what is a unit digit? It's really simple. It's just the last digit of any number, the one all the way on the right. So in a number like 579,032, the unit digit is 2. And here's the secret to this whole thing. To find the unit digit of a big, messy calculation, you only need to focus on the unit digits of the numbers you're working with. Everything else is, well, it's just noise. So here's our game plan. We'll start with the basics, which we just did. Then we'll cover 3 simple rules for different groups of numbers. And once we have those tools in our back pocket, we're going to go back and solve those puzzles we saw earlier. It's a journey, and by the end, you'll be a unit digit master. All right, let's start with our first shortcut. This is seriously the easiest rule of them all. It's a real quick win to get us started and build some momentum. So I want you to meet the 4 most predictable, most reliable digits in math. 0, 1, 5, and 6. What's so special about them? Well, no matter what power you raise them to, their unit digit will always be itself. Seriously, 5 to the power of 702 is going to end in a 5. 6 to the power of 528? Yep, it's going to end in a 6. They never change. And check this out. This shows you just how powerful that one little rule is. In a big problem like this, we can immediately solve chunks of it. The unit digit of 25 to any power? It's 5. The unit digit of 36 to any power? It's 6. And just like that, 2/3 of the problem is already done. Okay, so let's move on and see how this builds with our next set of numbers, 4 and 9. Now, these two follow a really simple, very, very predictable pattern. Now, what's really cool is the pattern that pops up. Look at the powers of 4. You get 4, 16, 64, 256. The unit digits go 4, 6, 4, 6. And for 9, you have 9, 81, 729. The unit digits go 9, 1, 9, 1. See it? It's just a simple, odd, even pattern. So here's the takeaway. From any number ending in 4, if the power is odd, the unit digit is 4. If the power is even, it's 6. And for a number ending in 9, if the power is odd, the unit digit is 9. If it's even, it's 1. That's it. All you have to do is just glance at the exponent and see if it's odd or even. And now, it's time for the main event. This is the master key. This is the concept that unlocks the final 4 digits, 2, 3, 7, and 8. And this is the trick that lets you solve pretty much any unit digit problem thrown at you. And that concept is called cyclicity. Just look at what happens when you calculate the powers of 2. The unit digits go 2, then 4, then 8, then 6. And then, when you get to 2 to the power of 5, the unit digit is 2 all over again. It repeats. This pattern of 4 just repeats forever. And the crazy thing is, the same thing happens for numbers ending in 3, 7, and 8. They all have this cycle of 4. So how do we use this? Well, it's a simple 4-step process. First, you just take the last 2 digits of the power. That's it. Second, you divide that number by 4. Third, whatever the remainder is, that becomes your new, tiny, easy-to-manage power. And here's the one special rule you got to remember. If the remainder is 0, you use 4 as the power. Not 0, okay? Always 4. Let's see it in action. So, to find the unit digit of 43 to the power of 46, we only care about 3 to the 46th. So we take the power, 46, and we divide it by 4. The remainder is 2. So our giant problem just became a tiny one. What's 3 squared? Well, it's 9, and that's our answer. Simple as that. All right, you've learned the rules. You've got the full toolkit now. So let's put on our puzzle solver hats and put it all together. Remember this guy? The problem that seemed totally impossible just a few minutes ago? Well, now it's just a simple 3-step puzzle. Okay, let's break it down. For 633 to the 23rd, we're really just looking at 3 to the 23rd. So 23 divided by 4 leaves a remainder of 3. And 3 cubed is 27, so the unit digit is 7. Got it. Next, for 277 to the 38th, we just need 7 to the 38th. 38 divided by 4 leaves a remainder of 2. 7 squared is 49, so that unit digit is 9. And finally, 266 to the 54th. Well, it ends in a 6, so the unit digit is always 6. That was easy. So our whole problem is just 7 minus 9 plus 6. Now for 7 minus 9, you can think of it as 17 minus 9, which is 8. Then 8 plus 6 is 14, so the unit digit is 4. And we solved it.
Let's try another one. This is a classic that tests our special rule. What is the last digit of 32 to the power of 32?
Okay, so the base ends in a 2, so we know we're using the cyclicity rule. We take the power, 32, and divide it by 4. Wait a minute, it divides perfectly. The remainder is 0, so we use our special rule and make the new power 4. So what's 2 to the power of 4? It's 16, so the last digit is 6. Perfect! All right, one final puzzle, this time with multiplication. This one combines a couple of our rules. Can you see the solution already? I bet you can. Okay, let's do this. First part, 4387 to the 245th. We only care about the 7, and for the power, we only care about the last two digits, 45. So divide 45 by 4, the remainder is 1. This whole thing just becomes 7 to the power of 1, which is just 7. Now the second part, 621 to the 72nd. It ends in a 1, so the rule is simple. The unit digit is always 1. Finally, we just do 7 times 1, which equals 7. And that's our answer. See? Easy. So there you have it. That's your complete unit digit toolkit. And it's all broken down into 3 simple ideas. You've got the unchanging numbers, you've got the odd-even pattern for 4 and 9, and you've got the master key, the cycle of 4 for everything else. With these tricks, you can crack the code of almost any unit digit problem you'll ever see. And, that really brings us to a bigger idea. What we really learned today isn't just some clever math trick. It's that the secret to solving really complex problems often isn't about brute force calculation. It's about finding the hidden pattern. So I'll leave you with this question. If a simple, repeating pattern contained these impossibly large numbers, what other hidden cycles and codes are out there all around us in the world, just waiting for a curious mind to notice them? Thanks for watching.